Hi, good afternoon, everybody. Just let me know if you all are hearing me clearly before we start. So the diagram, not drawn to scale, shows a circle with center O. The points A, B, C, and M are on the circumference. And they are telling us that the straight line CN is a tangent to the circle at the point C, right? And what else are they telling us? And it's perpendicular to BN, right? So basically that little description that they gave you there just relates to the diagram, right? So on the diagram here, this here represents my tangent. That's the tangent they're talking about, right? And they want us determine, given a reason for your answer. So the first part, they want angle ABC, right? ABC. So take a look at the diagram, and just before I work this, can somebody tell me what ABC is? All right, so take a look at the diagram. So before I work this, right? So as the series got 32 degrees already, right? Zachariah saying he wasn't able to find the quiz. It's there under the section trigonometry and geometry, right? Message me after class. I'll show you where it is. All right, so I'm seeing, all right, so Sharice got 32 and Tiffany also got 32. And she is saying because the angles in a semicircle is a right angle. All right, so here's what's going on here. So this one here, they want us, when you get a question like this, the first thing you need to do is to look at the diagram. So they want us to find angle ABC, right? So this is the process that I use. Now, I keep telling you all, I was a student at one point in time. I knew all the rules. They taught us the rules one by one. And then when they give us a question like this, you started to think, well, okay, which rule am I using? It could get a little confusing, right? So the first thing they want, you need to identify which angle they really want us to find. So they want us to find ABC. That is this angle here, right? Because this is A, this is B, and this is C. So angle ABC, they want us to get this angle here, right? Now, when they give us a circle geometry question, we have to apply some of the rules, right? Let me ask you all something. The line AB is called what? What is the line AB called? Alright, so I'm seeing everybody saying it's a diameter. That's great. It is a diameter, right? Now there is a rule when it comes to circle geometry that tells us what we are supposed to do with that. Alright? So the rule is the angle in a semicircle is 90 degrees. So if AB is a diameter, it means that this angle here, right? This angle here is 90 degrees. That angle is 90 degrees, right? So here is 90 degrees, right? So the question wants us to find ABC, which is this angle here. And we also know that when we add up the angles in a triangle, we should get 180 degrees, right? So angle ABC, which is what you want to find, so ABC is equal to, all we need to do is to say 180 degrees, take away 58 degrees plus 90 degrees, right? So this will give us, so we could use our trusty calculator to work this out, right? This question comes in your paper 2 most of the time. So you can use calculator for this, all right? So it's 58 plus 90, and that gives us 32 degrees, right? So this here is 32 degrees, right? So this here is 32 degrees, right? So you all are correct. Sharice and Tiffany, I think that's what you all said, 32, right? That is correct. So remember, with each of these questions, when they ask you to work out the angle, we need to give our reason, right? So let me show you how you're going to write your answer for this. So this is for part 1, right? So you're going to state that the angle in a semicircle is 90 degrees, right? That's what they want us. They want us to state that. You're going to get a mark for writing on that, right? And then what we're going to say is that angle ABC, so we're going to say angle ABC, right, is equal to 180 degrees minus 90 degrees plus, can't remember what the other angle, 58, right? Plus 58 degrees, and that is going to give us, how much it is, 32. All right, that gives me 32 degrees, right? So see this little piece here, you're getting 2 marks for this, right? This is what you're writing to get our 2 marks, right? So please, you need statements, you need to give reasons, right? So that is how we calculate angle ABC. Now, one of the tricks that you need to do when it comes to these questions, you need to write on the diagram. Now, you get to write on the exam paper, right? So whenever you work out an angle, please put the angle on the diagram. So this here is 32 degrees, right? So you know that, you worked out that already. Now let's look at the second part now. Part 2, they want us to work out angle CMB. So CMB, that's what they want us to work out here, right? So we go to the diagram and we look and try to find where CMB is. So this is C here, this is M, and this is B. So CMB is this angle here, right? So before I work this out, can somebody tell me what is angle CMB? All right, so just a reminder for the students who just started today, you're going to have to go back to the recording from the previous class in order to follow what's happening here, right? So I want to get angle CMB. So we're seeing Emma saying 122 degrees. All right, I've seen somebody else getting 22 degree, 122, right? All right, I think you're all on the right track here. So you want to get angle CMB, right? Now, after a while, the diagram starts to get a little cluttered, right? So there is a rule when it comes to a cyclic quadrilateral, right? So there's a rule when it comes to a cyclic quadrilateral, right? One sec, right? Let me just get something here for you all. So this is just for those students who weren't here last week, right? This is just a reminder. So we have something called a cyclic quadrilateral, right? So basically, a quadrilateral is a four-sided figure, right? And when we say that we're talking about a cyclic quadrilateral, each of the vertices of that quadrilateral lies on a circle. So A is lying on a circle, B is lying on a circle, C is lying on a circle, and D is lying on that same circle, right? And what we learned last week was that opposite angles in a cyclic quadrilateral are supplementary. What that means is that this angle here, this is A, and this is angle C. These are opposite angles. These two angles are opposite angles. And when we say they are supplementary, it means that A plus C must add up to 180 degrees. That is a rule, right? The angle B and the angle D in this cyclic quadrilateral, they are opposite. They are also supplementary, which means that B plus D is equal to 180 degrees, right? So this is the rule that we're going to have to use to answer that question. So let me go back to the diagram for the question. So if we look at the diagram carefully, we look at the points A, we look at B, we look at C, and we look at M. Those points all lie on the circumference of the same circle, and they form a shape which is a quadrilateral, which means that they are a cyclic quadrilateral we're talking about here. So what that means is that this, if you know this angle here is 58, you can figure out what this angle is here. So CMB, so angle CMB will simply be equal to 180 degrees minus 58 degrees, right? And that'll give us, I believe it'll give us the 122, 180 minus 58, you're going to get 122 degrees, right? So in terms of what you're going to write to get your full marks, right? Remember, it's not just about answering the question. You want to maximize your mark in the exam, right? So for the second part, what you're going to say, so this part 2, right? So you're going to say opposite angles in a cyclic quadrilateral are supplementary, right? So you need to say that somewhere in your answer. Right? And therefore angle, what it was, CMB is 180 minus 58. So angle CMB is equal to 180 degrees minus 58 degrees, which is equal to 122 degrees, right? So this is how you write in your answer to get your marks, right? Now let's look at the third part now. So that is 122. So we should write it in one time. So this angle here, right, is 122 degrees. We know that. So now we need to work out the last part, which is angle NCM, right? So angle NCM. So NCM, that's the first thing you need to do to figure out what angle they're talking about. This is NCM here, right? So before I work it, can anybody tell me what NCM is? Look carefully at the diagram, right? I know the diagram gets a little confusing after a while, but there isn't much we can do about that. So we want angle NCM. I see Tiffany saying 122. Zachariah saying a right angle triangle. Well, if you look carefully, all right, there is a right angle triangle there. CMN is a right angle triangle, all right? So CMN is a right angle triangle. You might need that in order to work it out. So look carefully what they want us to find. NCM is this angle here. This angle here. So I'm seeing Emma is saying 58 degrees. All right, so let's work this step by step, right? Look carefully at something here. So you saw the angle that we want to find, right? So you just worked out this angle here. This angle here is 122. CMB is 122. This here is 122. So let's work it step by step. What is this angle here? What is this angle here? That is CMN. What is CMN? So I want to know what is CMN. Yes, Zachariah, I think your answer might be right. Okay, but let's walk it through step by step. What is CMN? Tell me that angle first of all. So I've seen you all saying 58 degrees, right? So you can work out CMN. CMN is, this here is a straight angle. This line here, you have this line here. If you know that this is 122, this here, this is 122, right? I can work out what CMN is. CMN is simply 180 degrees minus 122 degrees, right? And that'll give me 58 degrees, right? So this angle here, that green angle you're seeing there, that is 58 degrees. That is 58 degrees here. But look, you have a right angle triangle here, right? The triangle CMN is a right angle triangle. So if you know one angle is 90 and one is 58, you can work out the angle they want us to find, right? So angle NCM right? Which is what they want us to find, right? That's what they're asking for, right? Which is this angle here, this angle here. That angle is equal to 180 degrees minus 58 degrees plus 90, right? And that'll give me, let's work that out. So 180 minus 58 plus 90, and you're going to get 32 degrees, right? So the answer for this one here is 32 degrees, right? I think Zachariah had said that. The answer is 32. So the final answer that they want is 32 degrees. So these questions, a lot of these questions, we have to use principles associated with certain angles, right? So let me ask you all, if you all kind of follow what we did there. So a circle geometry question in the exam could be easily 6 marks or 8 marks. So don't worry, this whole class we're going to look at past paper questions. That's what I'm doing for this whole class, right? You're going to see how they ask the questions, right? And don't worry, you'll get the notes for the class. I'll upload it just like I uploaded the others for you all. Alright, so that was May 2018. Let's look at the May 2017 paper. Now, one thing you should know, within the recent years, the actual exam question have gotten easier, much easier, I find, right? If we go back into the years, we're going to see the papers getting harder and harder, right? So, May 2017, you might be able to do this one very easily. So, here's what they're telling us here. We have PQRS are 4 points on the circumference of a circle shown, and they are telling us that angle QRS is 58 degrees. So basically all of this here is just telling us what we really seen on the diagram already, right? So the first part they want us to work out angle SPQ. Now SPQ, right? You need to look at the diagram and figure out what angle they're talking about. So this is S, this is P, and this is Q. So angle SPQ is this angle here. They want us to know what is that angle. So before I work that out, I want to see Chad saying he got that answer but he thought it was wrong. Chad, maths is all about confidence. Don't doubt yourself, right? Try not to doubt yourself in maths. Once you're working looking correct, chances are your answer is correct, right? Yeah, so SPQ. Before I work it out, can somebody tell me what is SPQ? What is SPQ? Alright, I see Emma saying 122. Anybody else want to give the answer? What do you think? So in order to answer any of these questions, we have to remember the rules, right? So calculating angle SPQ is very straightforward, right? I'm going to tell you why it's straightforward. It is because RSPQ, right? They are points or the vertices of a quadrilateral, right? And they all lie on the same circle. They all lie on the circumference of the same circle. Therefore, what we are looking at is a cyclic quadrilateral, right? So this is a cyclic quadrilateral. So I just gave you a rule, right? Well, just a reminder from what we did last week. We spoke about the opposite angles in a cyclic quadrilateral. They are supplementary, meaning that they add up to 180 degrees, right? That's one of the rules. So if we go back to the diagram, if I go back here, what that means is that this angle here, which is 58, plus this angle that we're trying to find here, it must add up to 180. So therefore, SPQ is simply equal to 180 degrees minus 58 degrees, right? Which is equal to 122 degrees, right? So yes, that is correct. The answer is 122 degrees. Right? So make sure that you know what angle they're asking you to find. They want SPQ. SPQ is this, right? So what we're looking at here is a cyclic quadrilateral. Therefore, opposite angles are supplementary. So all you need to do is to take 180 degrees minus 58 and you're going to get 122. So this angle here is 122 degrees, right? That's the answer for part 1. And the reason you're given is that RSPQ, this is the reason you're given here. All these questions, they want you to give a reason for the answer. So you get 1 mark for actually working out the angle, and the second mark is for giving you a reason. So you actually gain 1 mark for this, 1 mark for this. That's how they mark it, right? You can't just put 122 and expect to get full marks. You must give you a reason. Now, part 2, they want us to calculate OQS. OQS. So let's look and see where angle OQS is first of all. So we have O, that's the center of the circle, that's here, and QS. So the angle they want us to find is this angle here, right? So take a look at the diagram. I'll give you a few minutes to think about it and let me know what you think angle OQS is. Right? Again, to work this out, we're going to have to apply one of the rules that I taught you all last week. So we want angle OQS, which is this guy here. We want this angle here. Alright, so 32 degrees because the angle in center is twice the angle in circumference. Alright, so I'm seeing a lot of you all saying 32 degrees. Let's see if that's correct. So they want angle OQS, right? So make sure it's this angle we're looking for here. Now, if this angle here is 58 degrees, there's a rule that I gave you all last week. Alright, let me get it here so you all can see what I'm talking about. So that rule was this. This is what I said last week. I said that the angle at the center, which is this angle here, right, is twice the angle at the circumference. That's the rule for this one here. So AB, this AB here, this line here is what we call a chord, right? So we did this last week. And if we try to form an angle at the center, so if we form this angle here, we form a triangle here, and we form an angle here, right? And if we form another angle here, but we go on the circumference. The angle at the circumference, which is theta, is always a half of this, or we say the angle, so the rule is this. So the angle at the center is twice the angle at the circumference, right? All right. So what I suggest you all do, right? So the notes, I've given you all the notes for last week. You have an option of either you print the notes or you write it out in your own notebook, right? If you write it out, you might remember it better, right? So the angle at the center is twice the angle at the circumference. So let me see if you already answered this correctly. So if this is 58 degrees, then I can work out this angle here. I know what this angle is, right? That angle has to be twice or 2 times 58, right? So this angle here, right, which is angle SOQ, so SOQ, right, is equal to 2 multiplied by 58. Right, so 2 by 58, and that's going to give me 116. So that angle is 116 degrees, right? That's what this angle is here, 116 degrees. Now last week I also gave you all, I told you all that one of the shapes that we encounter a lot with circle geometry is an isosceles triangle, right? So triangle SOQ is an isosceles triangle because this length here is a radius and this length here is also a radius. So SO is equal to OQ, right? This is OQ, which is equal to a radius, right? So SO and OQ, they're the same length, right? So this is an isosceles triangle here, and if you know this angle is 116, this angle here, right, let me use a different color. So this angle here, I'm going to put this in green. This angle here and this angle here that they want us to find, they are the same angles, right? So therefore, all I need to do to find angle OQS, so OQS is simply equal to 180 degrees, right, minus 116 degrees, and I'm going to have to divide that by 2 because it's an isosceles triangle, and let's see what we get. So 180 minus 116, you get 64, and when we divide this by 2, we get 32 degrees. Right? So this answer that you're looking for here, which is this angle, this is 32 degrees. On this side here is also 32 degrees, right? Because it's an isosceles triangle. I think most of you all said 32 degrees. All right, good. And like Cherie said, the angle at the center is twice the angle at the circumference. That's the reason that they want for this question, right? So this is May 2017. Let me ask you all something. Are you okay with this one? All right. One second. All right, so I'm seeing most of you all saying yes. All right, cool. So that is May 2017. Let's move on to May, what is this one? May 2016, right? So this is May 2016. What do we have here? So usually they give you a little paragraph talking about what the diagram looks like. So the diagram, not drawn to scale, shows a circle with center O, right? And they are telling us that EH, so EH and EF are tangents to the circle. So remember what a tangent is. A tangent only touches one point on a circle, right? So therefore, this point here, H, right, is the point where the tangent cuts the circle or meets the circle. The point F is also this. So this here is a tangent, right? This line here is also a tangent, right? That's all they're telling you in words here. And FOG and JOH are straight lines. So where is FOG? Right, so FOG is this line here, this line that's going up here, this is a straight line, and JOH, that is going this way, this is a straight line here, right? And they told us that angle FEH, as this here, is 44. That's this angle across it, right? So they usually have a little paragraph talking about the diagram, right? You could read it, make sure there's no mistake. I've seen CXC make mistakes, right? So that's the diagram. Now, there are 4 things that they want us to work out here, right? So the first thing they want us to work out is angle EHF. So your first thing in your mind, so your thought process in order to work out this question is to go to the diagram and see if you can figure out what angle they want us to find. So EHF, where is E? E is across here. HF, right? So they want us to get this angle here. That is the angle that they want us to find. So angle EHF. Can anybody tell me what EHF is before I work it out? What is EHF? All right, so I'm seeing some of you all saying 68 degrees. Zachariah saying isosceles. Yes. So this was one of the rules that I gave you all last week. When you have a point that is outside, I don't know if you all remember this diagram. Let me get it for you. All right, I gave you all a diagram last week that looks like, where is it? Alright, so last week I gave you all a diagram that looks like this. I said when you have a point that's outside of the circle, so like you have this point here P, and you draw two tangents towards the circle, right? What's going to happen is that there's certain things that you need to look at. This diagram is basically symmetrical, right? And because this here is a tangent, right? And this line here is a radius, so this is a radius, right? It means that this angle here is 90 degrees. This angle here is also 90 degrees. The same thing on this side, 90 degrees, right? But also, right, what you can deduce is that you see this length here, the length BP, the length BP is equal to the length AP, right? So that's why you see I put these two lines here, right? Those two lengths are the same, right? So let's go back to the diagram now and see what we can use that for. So based on what I just told you there is that this length here, and this length here, they have to be the same. And what that means is that triangle HEF is really an isosceles triangle, right? Right, so I think Zachariah said that it's an isosceles triangle, right? So if that is an isosceles triangle, then we need to make use of that fact. If this is 44 degrees, right, this is the angle they want us to find here, right? Therefore, this angle here, right, let me put that in a different color here. So this angle here and this angle here, they are the same because it's an isosceles triangle. So therefore, to work out EHF, right, so EHF is simply 180 degrees minus 44 degrees, right? So you take away the 44 and you divide that answer by 2, and that will give us the answer that they want. So 180 degrees minus 44 divided by 2, you're going to get 68 degrees as your answer. So EHF is equal to 68 degrees, right? So I'm seeing several of you all actually got 68 degrees. Great job, right? So again, when you work out an angle, put it on the diagram. So this is 68 degrees. Here is also 68 degrees because it's an isosceles triangle, right? So that's as much as we know so far. The next thing they want us to find now is FGH. So FGH, you go to the diagram and you try to see where is FGH. So FGH is this angle here. FGH is this angle here, right? So what is angle FGH? Look at the diagram. Tell me what you think. I seen Tiffany saying 68 degrees. Anybody can say why? I feel Tiffany know the reason though. Now, if some of you all having trouble with the topic, I urge you all to look back at the class that was done last week, right? In order to become good at maths, you need to practice. It's all about practice, right? It's not something you're going to learn the night before exam, right? Practice, practice, practice. And that's what we're here to do, right? It's okay to get things wrong. That is fine. You learn when you get things wrong, right? I'm not going to buff you. I'm not going to do that, right? I want you to do well. Right, I have your best interest at heart here. Alright, so I see a few of you all saying 68 degrees. Alright. So out of all the rules, this is one of those rules that gives students some trouble. Honestly, when I was in Form 3, I had the same problem, right? I had a problem with this rule too, remembering it, right? So here's what this rule is. So when you're applying this particular rule here, we typically have a tangent. So you have a tangent to the circle, right? And that tangent is at the point E. It touches the circle at the point E. Then you have a chord. A chord is involved, right? So this is a chord, C-H-O-R-D, right? So AB is a chord, right? Oh, what did I write here? Oh, this is a tangent. I don't know what I was writing, tangle. Right, so this is a tangent, and the line AB is a chord, right? So between the tangent and the chord, I'm going to get an angle, right? And that angle here, we're calling that angle theta, right? Now that chord could also form an angle, right, on the circumference, right? So this angle here, so we had the chord AB, so this is A, and this is B, and we have some point on the circle, right? And we can form an angle here called theta. This angle here and this angle here are the same. That is one of the rules that you need to know. So a chord is involved and a tangent is involved at the same point, right? So let's say this angle here was 40 degrees. It means that this angle here is also 40 degrees, right? And the wording, right, for that rule is this. So the angle made by a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment, right? So all that fancy word is saying here is if this is 40 degrees, the angle on this side is 40 degrees. Now, let's go back to the question at hand. So the question, let's look at something carefully, right? Because the diagram could be a little confusing. So we know that this here is a tangent. That's a tangent. We also know that this line FH here, right? So this is here, CHORD. This is a chord. So if this is 68 degrees, and I use the points F and H to form an angle on the circumference, it means that this angle here has to be 68 degrees, right? So for part 2, there's actually no working. The answer is 68 degrees, right? And the answer is 68 degrees, but the reason that you have to give them is this reason that I gave you all here, which is this, right? You need to know this reason here. The angle made by a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment, right? So this is one of those things you're going to learn the night before, right? What I would do, what I suggest you do, you write all the rules on maybe 2 sheets of paper and you have that there the night before the exam, right? I mean, you're going to learn it now, but make sure you have it there as one of the things you need to learn just before you go in the exam, right? Because some students, they can't remember the wording for this rule, okay? So yes, the answer is 68. I saw some of you all say 68. Good job. Let's see, what did you all say? Right, so I see Danica saying basically what the rule is. Right. So that is FGH. The next angle that we want to work out now is JHE. So you go to the diagram again and you figure out where JHE is. So JHE, where is JHE? So right, so let me use a different color here so we don't get confused. So JHE is, look, this big angle here. Am I doing that correct? JHE. Yeah, so JHE, we're looking at this big angle here. JHE, this big angle here. What is JHE? This one is an easy one. It's a straightforward rule. Anybody? What is JHE? All right, so Tiffany saying is 90 degrees because point, right. So yes, that is correct, right? So I'm not going to go into much detail with that, right? So the angle between a tangent and a radius, right? But in this case, this whole line here, HJ, is actually a diameter, right? So that whole angle there is actually 90 degrees. So this is 90 degrees. So angle JHE is actually 90 degrees. And that is because the angle between a tangent and a radius is 90 degrees. So there's no calculation there for that part, right? So that's 90 degrees. So next one we want to work out now is GJH. So you go to the diagram and you figure out where is JGH. JGH. So JGH is this angle here. Let me use a different color here. So the angle they want here is this angle here, right? So they want this angle here. So what is JGH? So seeing Tiffany saying 22 degrees. How do you get that? Well, it can't be 22 degrees because you have that 60. It has to be something bigger than 68 degrees. So we want JGH, right? That's this angle here. This one. This angle, this whole angle here you want. That whole angle has to be more than 68. Alright, so I've seen a lot of you all saying 90 degrees. That is absolutely correct. That angle there is 90 degrees, right? And that is straight from one of the rules that we did, right? Which is the angle in a semicircle is 90 degrees, right? So let me just get this. This was the third rule that I gave you all last week. Right, so let me just get something here so you could get a recap. This is one of the rules that we did last week. We said that the angle in a semicircle is 90 degrees. So if you have, in this case here, CB is a diameter, and if we try to form an angle on the circumference, you're going to get 90 degrees, right? This is essentially what we're using here for this particular question, all right? All right, so this particular question, even though it looked a little complicated, it was pretty straightforward, right? So this is May 2016, right? I'm going to move on because I want to try to cover as much questions as I can in this class today, right? So you get a feel for the type of questions that come. So that is May 2016, right? So there wasn't a question in the May 2015 paper, but we have one here in 2014, right? So again, they usually give you a little paragraph talking about the diagram. So the diagram not drawn to scale. Now, let me tell you all something one time, right? So students who are weak in maths, please, I want you to remember that you see these diagrams, they're never drawn to scale, right? And CXC deliberately does that because they don't want students taking their protractor to go and measure the angle, right? So that is, you cannot use your protractor to work out any of these angles, right? They want you work everything using some form of calculation, right? So the diagrams are never drawn to scale. So please do not take your protractor and just measure the angle. You're going to get it wrong, right? So the diagram shows a circle with center O, The line BC is a tangent. So what they're telling us here, this line here is a tangent to the circle. So this is a tangent. All right. And let's see, what else? BC is a tangent to the circle. And they gave us two angles. So they gave us CBD is 42 degrees, right? So they're showing that in the diagram. And OBE is 20 degrees. So the first part of the question, right, as this part here, they want us to calculate angle BOE. So you go to the diagram and you try to figure out what angle they want. So they want BOE, which is this angle here, right? So I'm gonna give you all 2 minutes. What is angle BOE? All right, so let's see. Oh, okay. All right, so I've seen a lot of answers here already. I've seen a lot of you all saying 140 degrees. I feel that's wrong and right, you know. All right. So when you have these circle geometry questions, last week I told you all one of the triangles you need to pay attention to is an isosceles triangle, right? So if you look at something here, right, EO, right? So EO, all right, is equal to OB, right, which is the radius. That's the radius of the circle, right? Which means that this length here and this length here, they're the same. So therefore that triangle is an isosceles triangle. And if this here is 20 degrees, it means that this angle here is also 20 degrees, right? So therefore, you know that when you add up the angles in a triangle, you're going to get 180 degrees. So therefore, BOE is actually equal to 180 degrees minus, you know, the other two angles here would be 20. So it's 20 plus 20, right? So that's 180 minus 40. So that'll give me 140 degrees, right? So those of you all who worked it out, that is correct. 140 degrees, right? So good job. Right? Now the next angle they want us to work out now is OED. So where is OED now? OED, let me use a different color here. So this is O, this is E, and this is D. So OED is this angle here, right? This is what they want us to find. So how do we find OED? Anybody? What is OED? You all quick on the draw, eh? I've seen answers up already, 22. Alright, so I'm seeing Tiffany and Danica saying 22 degrees. To me, that's sounding about right, yeah? Let me show you why. So, look at something here. We have a tangent here. BD is a chord. This is a chord here. Right? So if BD is a chord, right? Remember, if we use a chord, that's BD here, and we try to form an angle on the circumference, right? That angle should be 42 degrees, right? That's the last rule that I showed you all, right? Let me just go back here. That's this rule here. The angle between a tangent and a chord, that's this angle here, right, is the same as this angle on top here, right? So if I go back to that diagram, let's use this here. So if this is 42 degrees here, right, there's the angle between the chord and the tangent, right? It means that this whole angle here that I'm drawing in blue, right, that whole angle there is actually 42 degrees as well, right? So if this whole angle here is 42 degrees and this small little piece here is 20 degrees, this piece here we just worked out is 20, and you could work out this green piece here. That green piece there, that's this angle here, is simply 42 degrees minus 20 degrees, right? Which will give us 22 degrees. So the answer for this part here, that's OED, is 22 degrees. So OED is simply equal to 42 degrees minus 20 degrees, and that'll give me 22 degrees, right? So that's the answer for part 2. And let's look at the last part now. The one angle BFE. So you go to the diagram and you say what BFE is. Where is BFE? Right, so BFE is this angle here that they want. This angle. So anybody, can you tell me what BFE is? What is BFE? So I see Emma getting 110 and she's getting 70 degrees. Tiffany getting 88. Oh, by the way, guys, if I didn't mention before, if you all are looking for the, I think I mentioned it in the group, right? All the past papers, the written papers, right, can be found on the CSEC Maths course page, right? I think I have from 2004. I have a significant amount of papers there that you all have access to, right? So don't need to go and buy any papers. All the papers are there. All right, let me see what you all doing now. So I've seen 3 different answers. 110, again seen 70, I've seen 88. So let me guide you all as to how you can this out. Now, remember we worked out BOE, right? That was 140 degrees. We worked this out here. So this angle inside here, this angle here is 140 degrees, right? We just worked that out. Now, there is a rule that says the angle at the center is twice the angle at the circumference, right? This line here, EB, is a chord, right? That's a chord. And that chord is forming an angle at the center, which is 140. Therefore, you can work out this angle here. The angle at the circumference will be half of that. So that angle there has to be 70 degrees, right? So that angle there is 70 degrees. But the angle that they want us to work out really and truly is this angle here. This angle here, right? But if you look carefully, FEDB is a cyclic quadrilateral, right? That is a cyclic quadrilateral. FEDB is a cyclic quadrilateral. So therefore, if I want to work out BFE, so BFE is simply 180 degrees minus 70 degrees. So you're going to get 110 degrees, right? I think somebody said 110. Yeah, so the angle is 110 degrees, right? So all I did, I applied two rules to work that out. I applied the rule that says the angle at the center is twice the angle at the circumference. I also said that I'm going to use the opposite angles in a cyclic quadrilateral is supplementary, right? Now what I want you all to do with respect to these questions, you can go ahead and practice them again, right? Now the notes here will obviously have the answers in it already, right? But you can go to the actual exam paper, right? Because I have all the past papers there. So go to the actual exam paper and practice doing the questions again, right? Only if you can't figure it out, then go to the solution that I'm giving you here, okay? So that is May 2014. Let me see, I need to get a few more questions inside here before we leave, right? So we have our next one here. So we have a diagram, not drawn to scale. It shows a circle, center O, and EBC. So this is the description, right? So this is the diagram that we have. The first thing that they want us to work out here is EBF, right? So the first part is EBF. So you go to the diagram and you try to figure out where this angle is. So EBF is this angle here, right? So that one is easy. What is EBF? So what is EBF? So I'm seeing Tiffany saying 55 degrees. Danica is also saying the same thing, right? That is correct because look at something here. So this line here, this line EC here, this is a tangent, right? This line here, BO, is a radius. So this is a radius. Right? So if that's a radius, the angle between a radius and a tangent is 90 degrees. So therefore, this whole angle here, this whole angle here is 90 degrees. Right? That whole angle is 90 degrees. So therefore, EBF, so EBF is simply equal to 90 degrees minus 35 degrees, right? And that'll give you 90 minus 35. You're going to get 55 degrees, right? So EBF is 55 degrees, right? So this here is 55 degrees, right? Right, so seeing Chad, Josiah, okay, so most of y'all got 55 degrees. Let's see what the next part is. So the next thing they want us to get is angle BOA. BOA is this angle here. All right, that's what they want us to find. All right, so what is angle BOE? Anybody? So everybody's saying 100 degrees. Right, I think that's talking about right. So here's what now the thing is, in some of these questions there are multiple ways you can work out some of these things, right? So here's what I would do. Right, it's up to you. You could have chosen something different. So BO is a radius, right? Now I could work out this angle here. I can work out this angle here now. This angle here is 50 degrees, right? Because I have a tangent and I have a radius. So this whole thing here, this whole thing coming here is actually 90 degrees. So that's how I can say that this angle here is 50 degrees. Now, if I use the last rule that I spoke to you all about, right? So this here, AB is a chord, right? AB is a chord, right? That's now, you want BOA. Actually, you know what? I'm sure you all worked it out an easier way using the isosceles triangle. So if this is 40 degrees, this here has to be 40 degrees as well, right? So therefore, to get this angle, it's simply 180 minus 40 plus 40. So BOA is equal to 180 degrees minus 40 degrees plus 40 degrees, right? Which will give me 100 degrees, right? So my method would have been a little longer, all right? But we'll get the same 100 degrees, right? So just use the fact that triangle BOA is isosceles, right? Because this length is a radius and this length on this side is also a radius, right? So BOA is 180 degrees. The next thing I want us to work out is AFB. So AFB, where is AFB? So AFB is this angle here. Again, this one is going to be easy. So this angle here was 100 degrees and I want to know what is AFB. All right, so everybody quick on the draw here. Everybody's saying 50 degrees, right? That seems about right to me. There's a rule for that, right? AB is a chord. AB is a chord, right? So if we try to form an angle at the center, which in this case is 100 degrees, then this angle on the circumference will be half that value. So therefore, this has to be 50 degrees. So 50 degrees is correct. You need to state the rule when you're giving your answer. Right, the angle at the center is twice the angle at the circumference. So that is why that angle is 50 degrees. Okay. And the last part, they want OAF. So look at the diagram and figure out where is OAF. So OAF is, let me get a different color here. It's starting to get a little clutter. So OAF is this angle here. That's the angle they want to find. So what is OAF? So Danica is saying 55 degrees. Let's see what everybody else is going to say. So the question wants this angle here, right? This OAF is this small angle here. That's what you want to find. Alright, so I'm seeing the answers as 15 degrees. It's sounding about right to me too. Now there are more than one ways to work out this particular one as well. Right? Now look at something here. Look at this triangle here. You have B. Okay, you have a triangle here, B, F, E, right? That's a triangle. If you look carefully, we have this angle here, which is 50. We have this whole angle here for the triangle here, which is 40 plus 35, right? So you have 40 plus 35, so you have that side here. So basically what you have is a triangle that looks like this. You have a triangle here, right? That looks like this. This is F, this is E, and this is B. This is 75, right? And this here is 50 degrees, right? And this here is the whole angle, right? That's this whole angle here, right? So all you do, you work out that angle there first of all. So that angle there is FAB. So FAB is equal to 180 minus 75 plus 50, right? And that will give me 180 minus brackets. That will give us 55 degrees, right? That is 55 degrees. So the whole angle is 55. But this little piece here is 40 degrees. So if you know the whole angle is 55 and that little piece here is 40, I can work out this piece here, which is what they're asking us, this green piece here. That green piece here is actually 55 minus 40 degrees, which will give me 15 degrees. So the answer is 15 degrees, right? So OAF is 15 degrees, right? So like I said, the diagram, it tends to get a little cluttered after a while, right? But writing on the diagram helps you to figure out the angles. Okay, so this is May 2013. All right, so I keep saying you need to practice these questions again, right? And practice them without looking at the answer first. Only go to the answer if you have problems. So that is May 2013. This is May 2012, right? So again, they give us a description. The diagram shows a circle with center O. The line UVW is a tangent to the circle, and ZOXW is a straight line, and they give us one angle, right? So that's all they give us, one angle, which is 70 degrees, and they want us to calculate the first part, which is angle OUZ. So when they give you the question, go to the diagram. So OUZ is where? Right, so OUZ is this angle here, right? What is OUZ? All right, I've seen Josiah saying 110. All right, Sanjana is also saying 110. All right, so let's take a look at this, right? Okay, so if you know this angle here is 70 degrees, all right, it means that you can work out this angle here, right? So that angle there, so this angle here is actually 180 minus 70, right? So that angle is 180 degrees minus 70 degrees, right? And that'll give me 110 degrees, right? So if that angle is 110, again you have an isosceles triangle here. This length and this length are the same. So if that's 110, it means that angle OUZ is simply equal to 180 degrees minus 110 minus 110, and you have to divide it by 2 because this angle here and this angle here, they're the same. So 180 minus 110 will give me 70, and 70 divided by 2 is going to give me 35 degrees. You're going to get 35 degrees, right? So the answer should be 35 degrees for angle OUZ, right? All right, so the angle there has to be 35 degrees as the answer, right? All right, cool. So next thing I want you to work out is UVY. UVY. Where is that? UV. So UVY is this angle here, right? That's the angle they want us to find. UVY. So let's put in some things that we know so far, right? So we know this angle here is 35 degrees. We also know that this angle here is also 35 degrees. This angle here is 35. All right. And the question wants to know what is this angle here. So what is UVY? I see Tiffany telling me 110. How you all getting 110? Try OUVX is not a cyclic quadrilateral. The vertices are not lying on a circle. So this line UW here, this here is a tangent, right? That's a tangent. This line here, which is OU, that's this line here. This line here is a radius. So therefore, this angle here is 90 degrees, right? Now, if this angle here is 35 degrees, then this angle across here also has to be 35 degrees, right? That's a rule that we learn. Angles in the same segment are equal, right? What that means is that this line here, this is our chord, right? And if we use this point O and X and we try to form an angle on the circumference, right? This angle here will be 35. If we try to form an angle using the same UX and some other point on the circle, this angle here will also be 35 degrees, right? As a rule, the angle or angles in the same segment are equal, right? So that's 35. We know that's 35. And you also know that this here is 90 degrees. So you have a right angle triangle. So to get this angle here, UVY, so to get that here, UVY, that is simply equal to 180 degrees minus 90 plus 35, and we will get you're going to get 55 degrees, right? So Shri is saying she lost, right? Now this one is pretty straightforward, you know. All right, we just worked out this. We got it 35 degrees, right? This is 35 degrees. We know we got that there. So we know this has to be 35 degrees as well, right? If you go back to the rules, go back to your notes from last week, we said angles in the same segment are equal. So this is 35 degrees. Then we know that the angle between a tangent and a radius is 90. This angle here, that is 90 degrees, you know. This is 90 degrees, right? So if you look carefully, you have a triangle, a right angle triangle that's here. These are the vertices of a right angle triangle. So this is 90, this is 90, this is 35. So all you're doing is working out this angle. It's 180 minus 90 plus 35. This is actually one of the easier ones. All right, Sharice, you still lost or it's making sense now? Right, so where we at now? Right, so that is UVY. So the last one now, we want angle UWO. So where is UWO? Let's see. So UWO is this angle here. This is the angle that they want here, right? So we know this is 55 degrees, right? So we want this angle here. Right, so anybody, UWO. All right, so I'm seeing a lot of you all saying 20 degrees, 20 degrees, all right? So this one as well, we have to make use of a triangle. Look at something here. I could get this as a different color, babe. All right, so I have a triangle here. This is one side of a triangle here, right? The next side of this triangle here is this here. This line that I put in here. And then we have our next line here going down here. So we have this triangle here. We know that this angle here is 70 degrees, right? And we also know that this angle here is 90 degrees. So therefore, all you're doing is working out this as if it's a triangle. So this one here is simply 180 degrees minus, and you're going to have to add 90 degrees plus 70 degrees, right? And this will be 20 degrees, right? So this answer here is 20 degrees, okay? So that's the answer for that one. All right, so I'm going to move on, right? If you all have any problems, you can always message me after, but look at the working and see if you can get the answers again. I want to see if I can squeeze in 2 more questions inside here. So that's May 2012. This is May 2011, right? So again, right, so they give you a diagram here, and they said that W, X, Y, and Z are points on the circumference. So once they say they are points on the circumference, you know they're forming a cyclic quadrilateral, right? And they're telling us that TYV, so this line here is a tangent, right? And they give us 2 angles. So this give us 64 and they give us 23. Calculate, given a reason for your answer, what is XYZ? So angle XYZ. So where is X, where is Y, and where is Z? So XYZ is this angle here, right? So they want to know what is that one. All right, so that one's straightforward. What is XYZ? So take a look at it. What is angle XYZ? It's very straightforward. It's directly one of the rules that we did. Alright, so I see some of you all saying 116. That's sounding about right. So look at this. You have X, you have Y, you have Z, and you have W, right? Those are 4 vertices. So therefore they're forming a cyclic quadrilateral, because all of them are on the same circumference, so the same circle, right? So we know that opposite angles in a cyclic quadrilateral are supplementary. So if this is 64 degrees here, then I can work this out. That angle is simply 180 degrees minus 64 degrees, right? And we will get 180 minus 64, and I'm going to get 116, right? So this is 116 degrees. All right, so that's the answer for that one, 116 degrees. Now, the next angle that we need to work out is YXZ. YXZ, where is that? So we know this is 116, so you write it on the diagram one time. So now you want to get YXZ. YX. Right, so they want angle YXZ, which is, make sure that's the correct angle they were looking for. Yeah, YXZ. So they want angle. Yeah, so they want this angle here. What is this angle here? So since she's saying 26, okay, she changing her mind. Tiffany's saying 23. Again, this one is straightforward as well, right? We're using one of the rules. That's a tangent, you have a chord here. This line here is a chord. YZ is a chord. So the angle between the tangent and the chord is 23 degrees. Therefore, this angle on this side here has to be 23 degrees as well, right? That is straight one of the rules that we know, all right? And that is the angle between a tangent and the chord, right, at the point of contact is the same as the angle in the alternate segment, right? That's how we state the law. So this here is 23 degrees. The answer is 23. And the last part, they want to find OXZ. So where is OXZ? OXZ is this angle here. So they want OXZ, but that one is straightforward. We've done several that looks like that. What is OXZ? So what is angle OXZ? Alright, so while you're all thinking about it, this is just a reminder. Remember, you all have access to the live classes for the Form 4 class as well, right? Which is on a Thursday, 5 to 7. For those of you who need a refresher, what we are doing right now is I've started over the topic of algebra, right? So we're doing simplification, we're doing, going to start factorizing, might be this week, I'm not sure, we'll see. Right, so if you need a refresher in algebra, feel free to join the class, right? So we want angle OXZ. That should be straightforward. Right, so I've seen a lot of you all saying 26 degrees. Let's see. So look at something here. You want to get this angle here. All right. Now, if this is 64 degrees here, then we can know what this angle is here. Because that angle will be twice or 2 times 64, right? So that angle there is the angle at the center, which is twice the angle at the circumference, right? So this angle here will be 2 times 64. So that is 6 and 6, 12. So that is 128 degrees. That's what that angle is here, right? Now, this triangle here is an isosceles triangle. So that is, so this angle here and this angle here will be the same. So therefore, to calculate OXZ, all you have to do is say 180 degrees minus 128 degrees, and we're going to divide that by 2, right? So 180 minus 128 and divided by 2, you're going to get 26 degrees, right? So I see a few of you all got 26 degrees. Good job. All right. So that takes care of 2011. Wow, this is good timing. And let me do the last one here before we go, right? Which is May 2010. Well, I catered for going up to May 2010 anyway. So in May 2010, right, they gave us a diagram and they gave us some wording, right? So they said PQ is a tangent to the circle, right? And they gave us this angle and they gave us this angle. So they want to know angle PTR. Right, so PTR is this angle here, right? This is angle PTR. Can anybody tell me what PTR is? So what is angle PTR? All right, I haven't seen any answers to PTR, right? Now, PTR, to look up PTR here, all right, this is one of the rules we're going to use again. So look at something here. PQ is a tangent, right? So PQ is a tangent. PR on this side here is a chord. This is CHORD, right? So look at something here. That 46 degrees here is the angle between a tangent and a chord, right? Now when I use that chord to form an angle here on the circumference, right, that will be this angle here. So therefore this angle here is simply 46 degrees. That's the last rule that we did. The angle between a tangent and a chord, right, is equal to the angle in the alternate segment. So if this is 46 degrees, this angle here that they want for PTR, this is 46 degrees, right? We're just applying the rule there. It's just that you're so accustomed seeing the diagram on the other direction, you may have missed it, right? So the answer is 46 degrees. The next thing they want us to find is TPR. Now TPR, where is TPR? So TPR is this angle here, right? How we get in TPR? That one should be easy. So what is angle TPR? So you want to work out TPR, right? That's this angle here, right? If you all look carefully, you're going to see we have a big triangle here. We have a big triangle here, look. This is PT, and you have a big triangle going across here. Right? This is a big triangle. Right? You know this angle here. This is 32 degrees. You know this is 46. So therefore you can work out this whole angle here. Right? So that whole angle, so therefore TPQ, that whole angle is equal to 180 degrees minus 46 degrees plus 32, right? And what you're going to get for that is 180 minus 46 plus 32. You're going to get 102. Right? So that whole angle is 102 degrees. So therefore the angle that they want us to find, which is TPR, so TPR is simply 102 degrees minus 56 degrees. And you're going to get 46 degrees. Hold on a second. I may have made a mistake there. Give me a sec. 180, so that's 46 and 32. That's all. Oh, okay. That's all. I made a mistake. It's one. This is 46. Yeah, 102 minus 46, right? And 102 minus 46, right, will give me 56 degrees, right? Sorry about that. So this is 56 here. So the answer is 56. Right, let me double check that. 102 minus 46. Yeah, 56 degrees, right? So this angle here that they want here is 56 degrees, right? My bad. Yeah, I made a mistake there. So it's 56, right? So this one is 56 degrees. And the last one they want is TSR. So TSR is this angle here. So you all should be able to figure that one easily. What is TSR? TSR. So TSR is this angle here. How do you get 90 degrees? So if you look carefully, look at something here. So T, P, R, and S are vertices, right, of a quadrilateral that's lying on a circle, which means that you have a cyclic quadrilateral. So if this angle here is 56 degrees, you can work this angle here easily because opposite angles, right, that is this angle and this angle here, they are supplementary, right? So therefore TSR, right, so TSR is equal to 180 degrees minus 56 degrees, right? So 180 minus 56, and you're going to get 124 degrees, right? So 124 degrees, right? So that's the answer for the last one, 124 degrees. I think I saw some of you all had that. Yeah, 124. All right. So, wow, that was real timing. So I actually had questions for you up until May 2010 in order to complete in the class, right? Which I have done, right? So that basically brings us to the end of circle geometry, right? There isn't anything else that I can show you that they can bring when it comes to these questions. So I've tackled all the May papers. So if you're all interested, you could attempt the January papers. So to start with January 2019, January 2018, just for your practice, right? And if you have a problem, you can always message me, right? Or I can just tell you what the answer is, right? So what we're going to be doing next week, so that's it for circle geometry. There's nothing else for me to teach you on circle geometry, right? So I'm still tinkering in my mind if I'm going to do vectors and matrices from next week or start it at the beginning of September, but I'll see, right? So for now, that's it. You all will have another circle geometry quiz to practice for me, right? I didn't check to see if everybody did it, but I keep reminding you all, the students that do well in the exam are the ones who do all my online assignments, all right? So if you all don't have any questions for me, all right, we will close off there. So let me ask, are there any questions? All right, so if you all don't have any questions for me, right, I will sign off there, right, and I will see you guys next week. Please be safe, right? The virus is still spreading, right? Like I said, you all are invited to attend the Form 4 class if you need a refresher on algebra, right? So take it easy, guys.